Hello students, welcome to the third video lecture on the topic surface chemistry. Today we are going to learn what is Langmuir's adsorption isotherm and applications of adsorption. Today we are also going to study definition of catalyst or what is catalyst. So yesterday we saw Freundlich adsorption isotherm. Mathematical expression for Freundlich adsorption isotherm is x upon m is equal to k into p raised to 1 upon n. So yesterday there was one mistake in my lecture. I told you Freundlich adsorption isotherm is not applicable at lower temperature and at higher temperature. It is applicable at moderate temperature. By mistake, it was told by me that Freundlich adsorption isotherm is applicable at optimum pressure. Optimum pressure is not correct. It is applicable over moderate pressure. Please note this point. Then I am going to explain Langmuir's adsorption isotherm. Its mathematical expression is also similar to Freundlich adsorption isotherm. X upon m is equal to AP divided by 1 plus BP. This is the mathematical expression for Langmuir's adsorption isotherm. I am going to rearrange this equation. I take this P on left hand side. The equation becomes x upon m divided by P is equal to A divided by 1 plus BP. So remember, I wrote this equation by taking P on left hand side. Next step, I am going to write, I take denominator into numerator and numerator into denominator for both the side of the equation. So I write P divided by x upon m is equal to 1 plus BP upon A. 1 plus BP upon A. I tell you the meaning of x and m. X is mass of adsorbent. X is equal to mass of adsorbate. M is equal to mass of adsorbent. A and B are the constants. Depending upon nature of adsorbate and adsorbent and temperature. P is equilibrium pressure. So the next step of this equation I write P divided by x upon m is equal to 1 upon a plus b upon a into p. This equation is similar to y is equal to mx plus c. Equation is similar to straight line. Equation is similar to straight line. So I am going to plot a graph. This is y-axis and this is x-axis. On x-axis I take P, pressure. On y-axis I am going to take P divided by x upon m. This is taken on y-axis. The nature of the graph is a straight line. The intercept, so this is the intercept on y-axis. This intercept is equal to 1 upon a. And the slope of the equation is equal to b upon a. Slope is equal to b upon a. So this is about Langmuir's adsorption isotherm. It gives the amount of gas adsorbed per gram of adsorbent is related to equilibrium pressure and is given by the equation x upon m is equal to ap upon 1 plus bp. So remember, this is Langmuir's adsorption isotherm and this is graphical representation of Langmuir's adsorption isotherm. The amount of gas adsorbed per gram of adsorbent is related to equilibrium pressure and is given by this equation. This is Langmuir's adsorption isotherm. After explaining this, I am going to explain applications of adsorption. So there are number of applications. We are going to explain some important applications within short time. I write the title Applications of adsorption. First application that I am going to explain, water purification. In purification of impure water, adsorption phenomenon is used. Look here, impure water contains mud particles, मातीचे कण असतात, plus vegetable particles and coloring matter. So this impure water is purified by using adsorption technique. The impure water is passed through the bed of the charcoal. Impure water is passed through the bed of the charcoal where insoluble impurities are adsorbed on charcoal and water gets purified Impure water is passed through the bed of the charcoal. Insoluble impurities are adsorbed on charcoal. Charcoal is good adsorbent due to its porous nature. Charcoal acts as filter. Now you see, the mud particles are purified by adding alum. तुरटी आपण पाण्यामध्ये ॲड करतो, तुरटी पाण्यामध्ये आपण फिरवतो. This alum forms colloidal particle of aluminum hydroxide. This is colloidal particle. So what are colloids? What is its size? We are going to study after 2-3 lectures. So this aluminum hydroxide is colloidal particle. On this particle, mud particles are adsorbed. This molecule becomes heavy. And settles down and water gets purified. So by using alum म्हणजे तुरटी, by using alum we can purify impure water. There is one more technique known as permutate process. In this process, impure water is passed through layers of zeolite. Zeolite is sodium, aluminium, silicate. Hard water contains Ca++ ions and Mg++ ions. This hard water is allowed to pass through the layers of zeolite, where Ca++ ions and Mg++ ions are adsorbed and give equivalent number of Na+ ions. Thus, hard water becomes soft. This is one more method of purification of water. Then, next method, ion exchange method. Water is purified by passing through ion exchange reagents. There are two types of ion exchange reagents: cation exchange reagent and anion exchange reagent. Water is allowed to percolate through cation exchange reagent, where Ca++ and Mg++ ions are adsorbed and exchanged by H+ ions. Then water is allowed to percolate through anion exchange reagent, where Cl- and SO4- ions are adsorbed and exchanged by OH minus ions. OH minus ions. So I think it is clear how the concept of adsorption is used in water purification. The second method I am going to explain, gas mask. Gas mask. Now you see, gas mask contains activated charcoal. So what is activated charcoal? That means the substance which contains higher percentage of carbon is burnt at higher temperature. Coconut shell is also burnt at higher temperature and it is called coconut charcoal. These are activated charcoals. Gas mask contains activated charcoal. This gas mask is used for breathing in coal mines. कोळशाच्या खाणीमध्ये gas mask वापरतात. The poisonous gases are adsorbed on charcoal and are adsorbed on charcoal while inhaling. So gas masks are used in coal mine. This is the second application of adsorption. Now I am going to explain third application of adsorption. Third method that I am going to explain is in separation of inert gases. You know that helium, neon, argon, krypton, xenon and radon, these are inert gases. These inert gases are separated by using the phenomenon of adsorption. Different gases adsorb to the different extent. Charcoal, activated charcoal or coconut charcoal is used for their separation. If it is clear, this is third. Fourth, for creation of high vacuum. To create high vacuum, adsorption technique is used. First, the vessel is evacuated by using vacuum pump. Then the same vessel is connected to another vessel which contains activated charcoal, which is cooled by liquid air. This activated charcoal adsorbs the moisture or air from vessel and high vacuum is created. After this, I am going to explain the next point, fifth application. That is to determine or in precipitation titrations. The example, consider the titration between sodium chloride versus silver nitrate. sodium chloride reacts with silver nitrate and forms white precipitate of silver chloride plus sodium nitrate. Ag reacts with chlorine and forms white precipitate of AgCl. In this titration, the indicators like fluorescein or eosine are used. In precipitation titrations, indicators like fluorescein or eosine are used. So here I represent burette. This is burette. This is stopcock. In this burette, silver nitrate solution is taken. This is conical flask. In this conical flask, NaCl solution is taken. Silver nitrate is added dropwise. When we add 1 drop of silver nitrate from burette, NaCl present in the flask reacts with silver nitrate and forms silver chloride precipitate. Here fluorescein indicator is also added before starting the reaction, before starting the titration. So like this you continue addition of silver nitrate. When all NaCl is reacted, that means when reaction is complete, this silver chloride precipitate adsorb excess of Ag plus ion on its surface. Silver chloride adsorbs the added extra drop of silver nitrate, that is Ag plus ion. This Ag plus ion adsorb coloring matter or coloring anion, negatively charged ion, from this fluorescein indicator, and the whole solution turns pink. That is the end point of the titration. So for creation of in precipitation titration, the concept of adsorption is used to determine end point. After completing this, I am going to explain the next application. The name of the application is froth flotation process. I write here froth flotation process. This froth flotation process is used in purification of sulfide ore, in separation of sulfide ore. फ्रोथ म्हणजे फेस, फ्लोटेशन म्हणजे तरंगणे. फ्रोथ flotation process is used to concentrate sulfide ore. For this purpose, pine oil is used. The hydrophobic part of pine oil acts as adsorbent. The sulfide ions are adsorbed on the hydrophobic part. The sulfide ore is adsorbed on the hydrophobic part of the pine oil and separates in the form of foam and floats on the surface, and it is separated. So this is one more application is used. Next application I am going to explain to control humidity, ardrata. Silica gel and alumina gel. Silica gel and alumina gel are used to control humidity. They are good adsorbent. They absorb moisture from the air. So to control humidity, adsorption technique is used. In column chromatography, adsorption technique is used to separate different constituents of the mixture. Suppose this is one test tube. It contains Fe+3 ions, which is yellow in color. Here is another test tube. It contains cupric ions, which are blue in color. This is third test tube, which contains CO++ ions, cobalt, which are pink in color. When we mix these three solutions, we get the mixture of these solutions. I represent like this, which contains Fe+3, Cu+2 and CO+2. These different constituents of the mixture can be separated by adsorption technique. So here is a long glass column. Suppose this is a long glass burette. Here silica gel is filled in this long glass column. Silica gel is good adsorbent. Or alumina gel. It is packed in this long glass tube. We are separating different constituents of the mixture by the technique of adsorption. Here is cotton. So this mixture is poured over this silica or alumina gel. When we pour this mixture, the mixture starts flowing down. At the top of the column, Fe+3 ions are adsorbed and form yellow band. Then below this Cu++ ions are adsorbed and forms blue band. And at the bottom CO++ ions are adsorbed and form pink band at the bottom. So by using adsorption technique, we can separate the different constituents of mixture. Chroma means color, chromatography. Colored components can be separated by this technique. It works on the principle that different constituents of the mixture are adsorbed on the same adsorbent to different extent. Different constituents are adsorbed on the same adsorbent to different extent. After completing this, I am going to explain one more point. So here I write catalyst. We are going to study the concept of catalysis in detail. So here I write KClO3, potassium chlorate. This potassium chlorate, when heated, it gives KCl plus O2. I balance the equation. I take 3 times O2 and here twice KClO3. Therefore, on right hand side, I take twice K. The reaction requires high temperature and the reaction is also very slow. Suppose the same reaction is carried out by using manganese dioxide, MnO2, which is black powder. When we use manganese dioxide, pinch of manganese dioxide, and potassium chlorate is heated, then the reaction takes place at lower temperature and the rate of the reaction is increased. The substance which increases the rate of the reaction without consuming in the reaction is called catalyst. Substance which increases the rate of the reaction without consuming in the reaction is called catalyst. Manganese dioxide acts as catalyst in this reaction. You know that this nickel is used as catalyst in hydrogenation of oil. Iron catalyst is used in the preparation of ammonia. Platinum is used as catalyst in the manufacture of H2SO4 by contact process. Platinized asbestos is used as catalyst in the oxidation of sulfur dioxide to sulfur trioxide. So in catalysis also the technique of adsorption is used. Large amount of gas is collected on small surface of catalyst. Thus, concentration of gas on the surface of catalyst increases and the rate of the reaction increases. So, the process in which rate of reaction is increased by using catalyst is called catalysis. So the concept of catalysis is used as application of adsorption. So we are going to study what is catalyst, what is catalysis in detail, not today but in the next video. Thanks for watching the video till the end. Thank you so much.